electrolytic cells. So in an electrolytic cell, a non-spontaneous redox reaction is made to occur by pumping electrical energy into the system. A general diagram for such cell is shown. The storage battery at the left provides a source of direct electric current. And from the terminals of the battery, two wires lead to the electrolytic cell. This consists of two electrodes, A and C, dipping into a solution containing ions M plus and X minus. So the battery acts as an electron pump, pushing electrons into the cathode C and removing them from the anode A. To maintain electrical neutrality, some process within the cell must consume electrons at C and liberate them at A. This process is an oxidation reduction reaction when carried out in an electrolytic cell, and it is called electrolysis. So at the cathode, an ion or molecule undergoes reduction by accepting electrons. And at the anode, electrons are produced by the oxidation of an ion or molecule. Okay. So we can differentiate a galvanic cell into an electrolytic cell. So, unlike in a galvanic cell, in which the current is generated spontaneously, in an electrolytic cell, a current must be applied by an external electrical power source for the reaction to occur. Okay, so we should take note on that. Again, galvanic or voltaic cell is a spontaneous reaction, while an electrolytic cell, it is a non-spontaneous redox reaction. So there is a simple relationship between the amount of electricity passed through an electrolytic cell and the amount of substances produced by oxidation or reduction at the electrodes. So we have here an example from the balanced half reactions. We have here Ag plus aqueous plus electron will yield to solid silver. So we can deduce that 1 mole of electron is equal to 1 mole of silver. So in the second half reaction, we have copper 2 plus aqueous plus 2 electrons will lead to copper solid. So we can conclude that 2 moles of electron is equal to 1 mole of copper. While the last one, Au3 plus or gold 3 plus 3 electrons will lead to gold solid or solid gold. So we have 3 moles of electrons is equal to 1 mole of gold. So relations of this type obtained from the balance equations can be used in many practical calculations involving electrolytic cells. So we need also to become familiar in certain electrical units, including those of first is the quantity of electrical charge. This is the common unit, and it is Coulomb C. The Coulomb is related to the charge carried by a mole of electron through the Faraday constant here. So 1 mole E is equal to 96,485 Coulomb. And the second one is the rate of current flow. Here the common unit is ampere or A. So when a current of 1 ampere passes through an electrical circuit, 1 coulomb passes a given point in the circuit in 1 second. So 1 ampere is equal to 1 coulomb per second. And we have the third one, the amount of electrical energy. This can be expressed in joules. When a charge of 1 coulomb C moves through a potential difference of 1 volt, it acquires an energy of 1 joule. So 1 joule is equal to 1 coulomb times 1 volt. So in this topic, we can examine the products of electrolysis and see how to predict the amounts of products to expect for a given flow of electric current. So let's try to have an example. Let's try to answer the self-assessment activity. So number 1, An electrolytic cell produces aluminum from aluminum oxide, Al2O3, at the rate of 10 kilograms a day. Assuming 100% yield, how many moles of electrons must pass through the cell in one day? Letter B, how many amperes are passing through the cell? And letter C, how many moles of oxygen are being produced simultaneously? So we have given here, given 10 kilogram Al or aluminum per day. And we have a half reaction. There. So we can deduce that in 1 mole of aluminum, we have 3 moles of electron. Okay, so there. So for us to calculate mole electron per day, we have so in 1 mole of aluminum, we have 26.98 grams. In 1 mole of aluminum, we have 3 moles, right, of electron. So we will have 1111.93 mole electron per day. Okay, we'll now solve for the rate of current flow. So we have 1111.93 moles electron per day. So we have 1 mole electron, 96,485 coulomb times in 1 day. We have 24 hours. So in 1 hour, we have 3,600 seconds. So our rate of current is 1,241.72 amperes. What we have left is coulomb per second, which is ampere. So for letter C, how many moles of oxygen are being produced simultaneously? So we have your other half reaction, which is O2 plus, O2 negative O2 plus E. So we can deduce that in 1 mole of O2, we have 1 mole electron. So we can use this value, 1111.93 mole electron per day. In 1 mole electron, we have 1 mole oxygen. We have 1111.93 moles oxygen per day. So there. So moles oxygen is different from mole electron per day. And if we are asked to calculate for how many grams of oxygen is produced, so we just need to multiply this one by its molecular weight, which is 32, I should say. So let's try to solve number 2. The electrolysis of an aqueous solution of sodium chloride has the overall equation: 2 molecules of water plus 2 chloride will yield 2 hydrogen gas, and chlorine gas plus 2 hydroxide. So during the electrolysis, 0.228 mole of electrons has passed through the cell. So letter A, how many molecules or how many electrons does this represent? Letter B, how many columns does this represent? And letter C, assuming 100% yield, what masses of hydrogen and chlorine gas are produced? So we have here letter A. So we have 0.228 mole electron. Okay. So in 1 mole electron, remember that we have 6.02 times 10 raised to 23 electrons. So moles, moles. So we have 1.37 times 10 raised to 23 electrons. Okay. So letter B, what is the column? How many columns does this represent? So the quantity of electrical charge. So we have 2.228 mole electron. In 1 mole electron, we have 96,485 columns. So we have 2.2 times 10 raised to 4 columns. Okay. So we'll now try to answer letter C. How many or what is the mass of H2 and Cl2 produced? So we have half reactions, which is 2Cl negative, Cl2 plus 2E. And we have the other one, which is 2H plus 2 electrons, H2. Okay. So from the given, we have 0.228 mole electron. Okay. So we can deduce that in 1 mole electron, we have 2. I'm sorry. In this equation, we have, or reaction, we have 2 moles electrons in 1 mole of chlorine. And in 1 mole chlorine, we have how many grams? 70.9 grams. So we have 8.08 grams Cl2. Okay. So let's try to solve for the amount of H2. So same, 0.228 mole electron. In 1 mole of H2, we have 2 moles electron times in 1 mole H2, we have 2 grams H2. So we have 0.228 grams hydrogen gas.